So in this video, you're not really going to see too many examples worked out, but what we're going to try to do is we're going to try to build some context for how you choose how to factor. Because right now we've been doing one piece at a time, and then to introduce something that you're going to see in the next video called factoring by grouping. And it's just going to give you an idea of what's out there before you saw the example. I thought that one example maybe wasn't enough. So this one's going to cover the why, and that one will show you the how. So let's first build our list of types of factoring and start building a general plan for factoring. So our list is going to include a type of factoring, and we haven't really titled those too much, but it's going to be helpful going forward. And assignments will be broken out that way. Do this kind of factoring, do this kind of factoring. Eventually, you'll need to know what kind of do when. Every type of factoring, it's important to know, it reverses some type of multiplication. And I think that reminding you that over and over and over again is helpful because factoring can be pretty tricky. And I think that knowing that it comes from distribution or something like that is going to be helpful. And then finally, this idea of planning, a general plan for factoring, to me, the signal is always the number of terms. That's why I've been highlighting that so much and emphasizing it. So let's take a look at the first kind of factoring we saw. At the time, we called it greatest common factor, and we really didn't use that over and over and over again because we weren't identifying it amidst other things. But the greatest common factor, it reversed distribution. So an example would be something like this. Here would be a distribution problem where they're saying, I see one term, it's outside of a set of parentheses. I know the way to multiply that would be to distribute it. And similarly, here's another problem where you have one term outside of a set of parentheses, and this time there's three terms inside the parentheses. And we know that if I ask you to multiply that, once again, that would be distribution. So if we distributed in the first example, we would expect to get two terms, 3a squared plus 15a, and you'd be able to see, because you just finished multiplying, oh yeah, there's the 3a that's hiding in there, and there's the 3 that's hiding in there, and then we just reversed that for factoring. We would say, well, if I was giving you this expression and the directions were factor, you would say, well, it appears that someone just distributed 3a into each of those because I can see it amongst the factors of each term. Let's park that 3a outside of a set of parentheses and then go through term by term and say what's left. Similarly, I might give you well, that would be a two-term expression, but I might give you a three-term expression. And I might be able to say, hey, could you factor that for me? And the answer is, well, yes, it just came from a distribution problem, or we know it's equivalent to a distribution problem. So there's certainly a way to factor it. And in that case, you would look across and you would say, let's see, there's three terms here. So I have to have a common factor to all three terms. They're all even. There's a 2 in there. I can see that there's x's in each of them. And I didn't say this in an earlier video, but it's pretty common that when we factor a common factor out, if the first term in your trinomial or binomial is negative, we tend to like to factor that negative out. You'll see why eventually we'd like to have a positive term inside here. So what we want to take away from that is, since you can factor this thing with three terms to become that, and you can factor this thing with two terms to become that, then that type of factoring, it can apply whether it's a two-term expression, a three-term expression. In fact, the matter is, I could have written bigger distribution problems, so that would work for 4 terms and 5 terms, and really there's no stopping that. So that's one type of factoring. The next type of factoring that we've been working on for the last week or so is factoring a trinomial. And that form, x squared plus bx plus c, you don't know it yet, but it's a particular kind where there's no number in front of x squared. Eventually, we'll have to go beyond a 1x squared, and we'll do more. But for now, it would be the reverse of a FOIL or a double distribution problem. Depends on how you're describing it to yourself. So here's an example of a multiplication problem that we're reversing when we factor a trinomial. And we know that FOIL is really, I've watched your work, and you really like FOIL more than anything else. But since we're going to try to reverse all types of factoring, double distribution is worth mentioning again. So the idea was we take the x minus 7 and we distribute it to the x. So we'll do that times that. And then we'll also distribute to the positive 4. So we'll see that. And we hopefully have done enough of these things that you see 4 terms. And then because of the symmetry that you see in these parentheses here, the x here and the x here, and the number here and the number here, it drives out this kind of symmetry with like terms that we tend to combine. But big picture, what has happened is this multiplication problem became that trinomial. So if we're talking about factoring, this trinomial should be able to be factored to become this multiplication problem. And we talked about how the numbers, the factors of negative 28 are a really big help. And finding the factors of negative 28 that add to negative 3 are really the way you got to get it done eventually. So we just learned that reminded you that you could factor a trinomial if it has 3 terms and has that right kind of symmetry to it. And you could find those factors of negative 28 in this case. So that'll be on our list. We have our list so far, greatest common factor that works for any number of terms. We have another thing that is the factoring a trinomial. That's if there's 3 terms with the right kind of symmetry. And the next video you're going to see is going to address factor by grouping. And the best way I can try to suggest grouping is this. Sometimes FOIL or double distribution doesn't simplify down to 3 terms. I ripped the symmetry out of this. Okay, there's no symmetry between this. Like there's not enough similarities in these parentheses. So when you do the double distribution, you end up with 4 terms that are all unlike. So I guess it would stand to reason that I could give you this 4-term expression, and if I teach you the right things, we should be able to factor it to this expression. So if that multiplication turns into this expression, then this expression should be able to factor that, but not until you learn factor by grouping. So in this video, all I wanted to point out was it's a new type of factor that's coming, and it applies for when there's 1, 2, 3, 4 terms. And the next video, Khan Academy video, will help you take care of the details. So that's where we'll leave this video, and you can pick up the learning on the next one.